Hello and welcome! I continue to go through my to-do box trying to repair expansion cards, and today I would like to take care of two original Creative Sound Blaster 16 sound cards. First one is a really nice Sound Blaster 16 with genuine OPL3 FM sound. The model is CT2290. The card has no slot bracket and I got it, as you see, some time ago. This card is not working, it doesn't even get initialized or detected because there are some broken traces on the back. As you see, I tested this card before and made a note for myself before I put it into the to-do box. Since it's been a long time ago, I don't remember the details. There are some spots on the PCB where the solder has been removed, and I'm not sure anymore if it was me. I also don't see the broken trace at the first glance, probably because it's too tiny. I guess last time I looked at it, I had no microscope, so let's use that. Yeah, obviously there it is. Let's thin the traces and add a wire to the broken trace. It is easier to solder a wire if you scratch free the affected trace a bit more, leaving traces nearby covered with solder mask. This way it is a lot easier to solder the wire to the trace. Just to give you an idea about how tiny those traces are, the silvery through holes around are 0.4 mm in diameter, and I think each trace is like 0.2 mm thick. So it's a lot easier to do this job with a microscope. There are multiple places on the PCB where the solder mask has been polished away. Probably there were multiple suspicious scratches, but only one seems to end up in a broken trace. It should be sufficient just to cover the exposed traces with nail varnish or solder mask, but I'll tin all the exposed traces to enforce those a little bit. Okay, let's give it a try. And yay, the card gets directly detected by the Unisound driver. Nice. Let's check the sound.
Zero, 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 zero.
Works fine. 8-bit, 16-bit stereo and OPL3 FM. No issues whatsoever. It is not necessary because I tint the traces, but I'll cover the spots with some nail varnish though. A slot bracket comes out of a 3D printer. Not perfect, but better than nothing. For most cases it works fine, but there are some cases for which it is a bit too thick. However, if I design the bracket thinner, it gets too unstable. So for some cases this is unfortunately not ideal and the lower part has to be cut. For others it fits and keeps the card nicely in place. So, and this was a fast success, even a bit too straightforward repair. That's why today I would like to try to repair something what I was looking at already a couple of times and was not very successful so far. A very long time ago I made a video about one nice 486 retro build where I wanted to use a similar Creative Sound Blaster 16, but unexpectedly the card failed. Back then I used another sound card and promised to come back to the failed Sound Blaster later. Maybe some of you remember that video? Write into the comments if you did watch my channel back then already. Would be nice to see if there are some long-term followers here. Anyway, after that I tried to repair the card once, but was unsuccessful and the card went into the to-do box. After that I got another working Sound Blaster 16 without a slot bracket, so I've stolen that from this card, and I also experimented with the Advanced Sound Processor, or short ASP, on another card which had an empty socket, so I borrowed the chip from this card. Unfortunately it became a donor, but I would like to bring it back to life. The card is completely dead, like paperweight. It doesn't get initialized or detected, doesn't give any signs of life whatsoever. As far as I remember, on my first attempt to repair it, I found that there was something wrong with the data bus transceiver and the buffer, which is a very common issue. So I replaced the chips, but that didn't make any difference. Unfortunately, I can't find the footage anymore, but today I will start where I stopped the last time. There was definitely something wrong with the data bus, and off camera I made some measurements and found following. There are two pull-up resistor networks around the buffer, which are built in the following way. All of the pins from 2 to 5 are connected through an internal 1K resistor to the pin 1. Now, when I measure the resistance between the pins, I see 1K on the second pin, 1K on the third, but only 390 ohm on the fourth, and 390 ohm on the fifth. Sure, the resistors are in circuit and the effective resistance could, in theory, be different for each one, but since all of the pins are connected to the same data bus, they actually should be all nearly the same. Since the values are different, it is a good sign that either the chips on the bus, which I already replaced, are also bad, or the resistor network died. So let's remove the resistor network and measure it out of the circuit again. So the resistor network is out. Let's see what we measure now. Infinite resistance between pin 1 and 2. Same on pin 3. Same on pin 4. And 5. Does the multimeter work? Yes, seems to be okay. So we have infinite resistance on the bus. That means that the resistor network is dead. Let's check. Here we have 1K. Here again 1K. Look at that, 370 ohm. That one is faulty. Well, the last pin the same. The resistor network is toast. I went through my spare parts and unfortunately didn't find the required resistor network, so I'm going to build it out of 4 normal through-hole 1K resistors. Looks good. Let's give it a try. Unfortunately, the card still doesn't get detected. There have to be more faults on that card. So I wanted to check the data lines on the bus transceiver and see if it gets enabled at all. The 74LS245 has the low active output enable input on pin 19. And when I measure it, it looks very odd. I would expect it to be always high or low, or switching properly between high and low. If you look at this input, it seems to stuck at 5 volts high, but has strange peaks down which are, well, neither high nor low. They should either not be there at all or go all the way down to 0. This doesn't look right. So the output enable signal from pin 19 on the bus transceiver is connected to this 74LS08 pack of AND gates. This pin 3 is the output of the first AND gate, which inputs are on pin 1 and 2. Let's see what we get there once again. This is pin 2 of the AND gate, and I can clearly see that the signal goes from high all the way down to low. On pin 1 the same, it switches between 5 volts and 0 volts. But the output of that AND gate looks like this. I don't know what you think, but for me it looks like an absolute garbage. Let's replace this chip as well. Okay, now let's check if there is some improvement of the output enable signal. Oh yes, this looks much better now. Now the signal doesn't jitter around 5 volts anymore, but goes all the way down to 0 volts. Let's check if the card works now. And would you look at that? We have the initialization. This sound card is not plug and play, but Unisound driver is still able to initialize it. Let's check the sound. Okay, this is a good sign. Also, Wolfenstein 3D detects the Sound Blaster, and there is even music. Okay, there is no digital sound. Unfortunately, the same in Descent 2 setup utility. There is no digital sound, only FM. So I doubled and triple checked everything, but unfortunately I have no clue what is going on. I looked through the documentation and found this Sound Blaster programming guide, in particular this block diagram which shows Sound Blaster 16 advanced signal processing. Here below we can see that the FM sound is connected directly to the mixer and we hear the FM sound. However, the digital sound path goes through CT1748 into the digital to analog converter. On the card, which I tried to repair, I removed the chip because I used it in another card to experiment with the ASP feature. And this is strange since there are plenty of Sound Blaster 16 cards out there which don't have CT1748 soldered or just have an empty socket, considering that chip optional. That is what I assumed as well for this card. I'm not sure at all if there is no digital sound because the chip is missing now, but I guess there is only one way to find out. However, that chip is quite rare and I don't want to expose it to unnecessary heat again. Especially if that chip is unrelated, I would have to desolder it again to put into another card. So instead of soldering it, I'd rather add a socket here. So the socket is installed. Let's insert the chip and give it another try.
0, 0, 0.
Wow, there is digital sound.
0, 0, 0.
I really didn't expect that. As I said, there are many revisions of the Sound Blaster 16 where that CT1748 chip is optional and they all work just fine without that. On this model, obviously, the chip is mandatory. Well, what a surprise! Okay, the card works. Now it's time to make it look nicer again. First of all, the game port lost its metal cover, as you see, and I don't have a replacement, so I'm going to replace the whole part, which I have plenty of because the USB game port adapter which I made once. Oh, good that I removed that. There seems to be some oxidation below. Let's clean, polish and tin the contacts. So there they are, 2 working Sound Blaster 16 cards. I'm especially glad about the upper one. It had to wait for a very long time. It was almost abandoned and became a donor. I took the ASP chip from it because I was convinced that it was optional, like on many other similar cards. As you see on the second card, the chip is not soldered at all. I don't know what exactly is different between these cards and why this one works, despite that the chip is not soldered. The parts around are very similar. The small resistors and capacitors seem to be the same on both cards. On this card, however, there is a chip which is missing on the other one. Therefore, here we have two programmable logic ICs which maybe do the magic and are responsible for some ASP detection logic, so the card can work with and without CT1748 chip. But that's just an educated guess. And for today, this is it. There are two Happy Sound cards back from the retrograve. I hope you found this repair interesting. At least I did. It took me some time and a couple of retries. I had to replace quite a lot of parts. Transceiver, buffer and broken capacitor, which I didn't mention yet, a resistor network and, last but not least, an AND gate. But eventually the story found its happy end. As always, thank you for watching and goodbye.